Why is AI referred to as intelligent, and how does it actually achieve that appearance? Why do we call it artificial intelligence? After all, today's AI doesn't feel emotions, doesn't have consciousness, and, according to many philosophers and researchers, doesn't truly understand anything the way humans do. So why the word intelligent? It goes back to 1955-1956. Computer scientist John McCarthy coined the term artificial intelligence for a summer workshop. He and his colleagues defined the goal very practically: make machines behave in ways that would be called intelligent if a human were doing the same thing. That definition stuck. AI isn't claiming machines have minds or souls. It's about performance. If a system solves problems, learns, reasons, speaks, or creates at a level we'd call smart in a person, then we label the technology intelligent. It's an operational label, not a philosophical claim about inner life. So how does modern AI, especially the large language models and multimodal systems we use in 2026, pull off this impressive, intelligent-seeming behavior? The core trick is prediction at massive scale. Almost every powerful AI today is built on deep neural networks trained to predict the next piece of data. For language models, right-pointing arrow predict the next word, or token, in huge amounts of text. For image models, right-pointing arrow predict the next pixel or patch. For video or multimodal systems, right-pointing arrow predict the next frame, sound, or action. They do this by adjusting billions to trillions of internal parameters, connections, during training. Imagine feeding the model almost the entire internet's worth of text, code, books, dialogues, articles, then asking, given everything that came before, what's the most likely next word? Over time, the network learns incredibly rich statistical patterns, grammar and syntax, facts and common sense associations, logical reasoning steps, because humans write explanations that way, style, tone, even apparent creativity. When the model is big enough, the training data diverse enough, and the compute massive enough, these patterns become so fine-grained that the output looks like understanding, planning, and intelligence. Philosophers sometimes call this competence without comprehension. It produces correct or useful answers without having a real mental model of the world. In 2026, we see systems that chain multiple reasoning steps, chain of thought, use tools and external memory to correct mistakes, handle very long contexts, appear to plan and reflect, all emerging from the same next token prediction engine, just scaled up, fine-tuned, and combined with clever engineering. But here's the important nuance. Most experts agree this is still narrow, pattern-based intelligence, extremely capable in trained domains, brittle outside them, and lacking true causal understanding or grounded common sense that a toddler gets from interacting with the physical world.